Find P for which the integral converges. The first one is,
I knew it was one.
now we got some stuff going on the limits of integration. We've got a 2 to infinity. What P? And P for which the integral converges.
Physics and Wednesday.
So since 1 and 0 are not in the region of integration, my denominator is well defined for all values of x. This is what makes the integral improper. So we're going to put a letter there and make a proper integral out of it. I'll use a capital N. I think the limit is n goes to infinity and integrate this from 2 to n. As we normally would. We have integrals that have a natural log in it. We typically choose that to be u. So we'll let u be the natural log of x. That means that du is the rest of the integral, 1 over x times dx. So here's the 1 over x and the dx. So we're integrating u to the negative p du. That part okay?
Yes, the first one was doable.
So we add 1 to the power and divide by the new power. We have u to the minus p plus 1 divided by minus p plus 1. Let's go ahead and put that back in terms of logarithms. And then I'll put the limits of integration in there. U was the natural log of x. We want to evaluate that from 2 to infinity. Or 2 to n, and then we'll let n go to infinity. So we have the limit, n goes to infinity, natural log of n, minus p plus 1, minus the natural log of 2 to the minus p plus 1 over minus p plus 1. So the natural log of 2 is defined for any power. Natural log of 2 is just a constant. Either of these fractions are undefined when p is equal to 1. So we can't have p equal to 1. Then this is a growing function. And the only way for this limit to exist is if my growing function ends up in the denominator. So what value of p makes this thing end up in the denominator?
Greater than 1.
Right? So we will need this in the denominator. So the minus p plus 1 needs to be negative. And so if I solve this for p has to be bigger than 1, strictly bigger than 1. So this integral converges when p is strictly bigger than 1. And it'll converge. When p is bigger than 1, that's in the denominator. And so the limit will go to 0, agree? And so it'll converge to this number. Part B. And we have the natural log of x in the numerator, x to the p in the denominator. And
2 to infinity.
same limits of integration, 2 to infinity. So again, I'm going to write that as a limit. N goes to infinity of 2 to the n. Let me write that as x to the minus p natural log of x dx. So it's no longer a u du integral unless that p was equal to 1. But in general, how do we do an integral that looks like that? Integration by parts. Integration by parts. U is still the log of x, but we're going to do integration by parts. So du is 1 over x. And now I'm going to integrate this, and I get x to the minus p plus 1 over minus p plus 1. See if I can move over any. Do some over there. I will. Okay, so we're going to go uv minus the integral v du. Let's do it from here. uv. So there's no pretty way to write that. That's the natural log of x. That's going to be evaluated from 2 to n. Minus the integral of v times du. And then I still have that limit out here. So let's simplify this a nudge, and then I'll take care of that.
Does it get rid of the 1?
It does, because when you simplify here, you subtract exponents. I have an x to the 1, an x to the minus p plus 1, so it gets rid of this 1. So we're left to integrate. And pull my constant out. We're left to integrate x to the minus p.
That's what I was missing.
And now you're going to integrate that by adding 1 to the power and dividing by the new power. You get x to the minus p plus 1 over another minus p plus 1. So my antiderivative, one more line I could fit here, is going to look like x to the minus p plus 1 over minus p plus 1 natural log of x. Let me leave that off for a minute. Then I've got a pair of those. So I'm going to write that as the quantity squared. Then I'm going to evaluate that from 2 to n. Put that out over here and come back over to this side of the board. Are you okay there? Okay, so let me even make it easier to read. I've got a common factor of this. I'm gonna pull it out. And then in the other factor, I'll have a natural log of x minus, I guess I'll have one of these. Right? And that's just gonna be a constant. So I'm gonna factor out x to the minus p plus 1 minus p plus 1, leaving me with the natural log of x minus one of those right there. And then we can evaluate that from 2 to n. Let's see. Guess I can keep writing over here. Can you guys see? Let me see if I write up here. Okay, so x becomes n. So we have n to the minus p plus 1 over minus p plus 1. Natural log of n minus 1 over minus p plus 1 minus, oh, go up a bit. Now x is 2. And so we have 2 to the minus p plus 1 minus p plus 1 times the natural log of 2 minus 1 over minus p plus 1. But all of this is just a constant, right? That's what we need to worry about. Okay, that's a problem.
You just need to move the end to the bottom of that one.
Yep. Then you get infinity, right? Because ln then approaches infinity is infinity.
Right.
Well, if we didn't factor it out, couldn't we make the ln part of a fraction and then do L'Hopital's?
Yes.
Or the tower of power just tells us that exponentials grow faster than natural logs.
But it'd still be right. Okay, so you're right. I got a couple things I need to consider how I'm going to write this so that you guys will understand everything that was just said here.
Infinities are bigger than others.
Some infinities are bigger than others. Okay. How about, let me, how am I gonna write this? I am gonna write this like let's see if you like this. I'm gonna get a common denominator in here. So I'm gonna multiply that by minus p plus 1 over minus p plus 1. I'm gonna put that in there. And I'm gonna have the natural log of n minus 1 over minus p plus 1 squared. Wait a minute, I need a minus p plus 1 here. Now I gotta worry about where I'm gonna put him. And I'm gonna put him here. You agree that that is the same as that?
Yes.
I got a common denominator in here of minus p plus 1. I distributed that, gives us a minus p plus 1 squared. And then I put that on the bottom so that this looks like infinity over, in some cases, infinity. This will be infinity if this stays put. But if this has a negative power, then it goes upstairs and becomes a 0. But I want infinity over infinity. Okay, so in order to do this limit, I need infinity over infinity. So in order for this step to be valid, what do I need P to be?
Greater than 1.
1 minus P has to already be positive. So P has to be smaller than 1.
Wait,
Yeah.
isn't it P minus 1? Because you.
When I moved it down, I changed the sign.
Right, and so 1 minus P is the same
Oh,
thing.
yeah. Yeah, okay, so I moved it down and I changed the sign. So that becomes P minus 1. So I need P minus 1 to be a positive thing after I move it down. So P has to be bigger than 1. Now I gotta see if P is bigger than 1, will this limit exist? But the limit does exist because of the tower of power. This grows faster than the logarithm. That's a constant, so it's not gonna change things. So this limit will be 0 if P is bigger than 1. And then this step was able to be done if P was different than 1. If P is equal to 1, then we have the same problem that we had a minute ago. If P is equal to 1, I just have a UDU, and it's not going to converge as n goes to infinity because the logarithm will end up on top. Right? The only thing that's going to damp it down small enough is that this power is strictly bigger than 1. So this thing converges only for P larger than 1. Okay. Yeah, I can see where that's a little bit tough analysis right there.
Do we have any questions similar to this on the test?
Yes.
Do you want one?
No.
Extra credit.
Extra credit, I'll take an extra credit.
Extra credit.
I haven't written the test yet. What is it?
It's
tomorrow.
due Wednesday.
It's Wednesday.
You've got 2 days. You have
Do
time.
tomorrow.
Oh,
Do tomorrow.
That means do
I got a trade test tomorrow I gotta write.
And that means you can do it.
And I can do 4 versions of it, because they're little cheaters. No, they're not cheating on purpose. They're packed in a small room tightly together. They can't help but see everybody else's papers.
Just absurd.
That excuse is never worked for me.
But this class is spread out enough that I can walk up to you and smack you if you're looking around. That class, I can't get into the rows, so I need like a BB gun.
That would be an nerve gun.
Airsoft. Oh, airsoft gun.
Wait, no, I could also get expelled.
I think I still have some airsoft guns from when my kids were little.
Little spring.
What else you want to talk about?
How was your day?
Good, thank you.
Honestly, could we review like the rule stuff on whenever like you have 2 trig functions and like n needs to be greater than n or
Oh,
whatever, like how to
Sine times
like the
cosine.
little,
Secant
How do you
table.
know?
Yeah, even
like the
odd.
little
one's
rules that
even
we
odd.
went, yeah, that the even and the odd, like if tangent is even, you do this, whatever.
Yeah, I never know that one. I just kind of play with it.
Okay.
Tangents and secants, I just play with. I don't have the rule memorized. Tangent is secant squared. So if u is tangent, du is secant squared. Does that substitution leave you an even secant to sub out with a Pythagorean identity? Or if u is secant, du is secant tangent, does that leave you with an even tangent to substitute out with a Pythagorean identity? After you pull out a tangent, right? So I don't know. I don't know until I do it.
What are some trick subs that we're all rocky on?
Here, let me write one while I clear the board and see if you can do this one. This was from an exam a long time ago.
How long ago?
Spring of 2014. Were you born?
I don't think so.
I was. Let's see if you can do that one while I erase the board. Let me move that over so these people can see it. There it is. Cosecant squared of 3x divided by the cotangent of 3x. You said, ooh, and it's really not a hard
Not bad.
integral.
No,
You, right?
Yep. I suppose if you're not comfortable with secants and cosecants, you can also write this in terms of sines and cosines and maybe be able to handle it from there.
It was a cosecant cubed on top.
But if you remember that the cosecant has as its derivative, no, cotangent, they're gonna take the bottom to be u. Never take the top to be u, take the bottom to be u. What is the derivative of a cotangent? Negative cosecant squared. So the derivative here is a negative cosecant squared of 3x times the 3, right? So a negative 1/3 du is the numerator. Yeah. So I'm going to get a negative 1/3. That's the du. So 1/u du. Right? Everybody see where that came from? So I got a natural logarithm. And u was cotangent of 3x. All right. And you do this one. Done?
This is a formula.
That's a formula. Remember it?
I'm thinking.
I believe in you, Jack.
I reviewed this last night.
You know what? I had help with flashcards.
Yeah.
Did you use them in the shower?
All right, so those of you who got that one,
No,
you
not the
remember this
shower.
one?
I do, I really do.
You know where I can get them
That's a
laminated?
formula as well. Number 2 and number 3. Number 3 you could do with u du if you change it to sines and cosines. But if you remember the formula, it'll save you a step.
Number 2, secant tangent, ln secant tangent.
Secant plus tangent.
Yeah.
Natural log of the secant of x plus the tangent of x. Okay, what'd you get for this one? Natural log of the secant minus the natural log of the cosine. Either one if you remember the best. Okay. The next one, suppose you want to integrate secant squared. Another memorized thing. The function has as its derivative secant squared is the tangent. So the integral secant squared is the tangent. So if you have any combinations of tangent to whatever power, right? Whatever power, even, odd, rational, irrational, this is a u du integral, right? Take u to be tangent of x. So the presence of the secant squared is good.
Does that also apply for any
Any
even or?
even secant should follow the same pattern. Any even secant, I would be able to get a secant squared out of it, leaving me with even secants to get rid of with Pythagorean identity. So u is tangent of x if this is secant squared, or if this is any even number here. What's the trig identity to get rid of even powers of secant? Is that right? So if this were any even number, pull two of them out, and the remainder.
Yeah, 10 squared.
Oh, yes, right.
Oh.
That's an interesting way to write it too. Bottom of the.
And so any even number, this strategy works. All right. What about 1, 2, 3, 4, 5? This one. Tangent squared of x dx.
Because then you know secant squared.
What you got? Because here's the key to success. We know how to integrate both of those, and tangent squared is equivalent to that. So just use a trig identity. Integral of tangent is secant squared. Integral of 1 is x. Okay. So now we're on. Those are the easy ones. Those are the ones we have memorized. So how about number 6 will be tangent cubed. Think about a tangent cubed of x.
So you would still take u to be tan x because if secant to the 0, does that still count like as an even power?
Right, but we need to position ourselves with the secant squared over there somehow. Right, that is a tangent squared times a tangent. So I'm gonna move the tangent squared. If we have a tangent, we need a secant squared, so that's why we got him here. So now we can use that trig identity and put in a secant squared minus 1. And break this up into 2 integrals, the u du integral. And then the known integral. Right? So here u is tangent, du is secant squared. So this integral is just the integral of u du. We get u squared over 2. And then here we just did the integral of tangent a second ago, minus either the natural log of secant or minus the natural log of cosine, whichever you prefer. Okay. And so let's take a tangent cubed times a secant as number 7. Tangent cubed times secant. So I don't have an even number on the secant. My strategy now changes. Maybe. What do you think? And what's the derivative of secant? So I need a secant tangent in here.
Wow, 1 tangent.
Pull out a secant tangent and write the rest in terms of secant. Not a secant tangent, write the rest in terms of secant. I'm gonna have a tangent squared left when I take one of those tangents away. Tangent I took away is right here, positioned to be the du. So you have to kind of think backwards, get your du set up and then make your u appear in the rest of the integral. So I've got to replace the tangent squared with secant squared minus 1. So we're integrating u squared minus 1 du. Cubed over 3 minus u. Each u is a secant of x. So you kind of need an odd power on tangent for that to happen, right? That'll work for any odd power on tangent. But as long as the secant isn't even. Any even secant, you go that route. Right, so if this is secant squared, I do that. But if this is tan cubed, secant cubed, this will still work. You see that? An odd power here, keep an odd power there, that should work. Put an even power here, any power there, that should work. So the goofy case was what? Odd here. Well, if that's even, it's still cool. Yeah, if this is even, then I'm in trouble, right? This is even, then we're in trouble. And this one's odd.
You do.
Then you have to integrate by parts. So do you remember how to integrate secant cubed? Try that one next. The integral of secant cubed. Example number 8. Can't take out a secant squared. We can't take out a secant tangent. We will take out a secant squared. But we'll take out a secant squared to do integration by parts. So from there, you can do uv minus the integral of b du. I'll give you a chance to try. It's going to go circular. So if you can catch where it becomes circular.
gonna walk around while you're integrating.
First step. Secant squared dx is what you can integrate. Actually, you can integrate both, but you pick the biggest. It gives you the secant of x. Du secant tangent. And V is the tangent, right? And so our uv minus the integral of v du becomes secant of x tangent of x
I missed one. I think I missed a sign.
minus the integral of v du. V du is secant tan squared. Go with my pen. V du is secant of x tan squared of x. Okay, which what? That was the case where we can't pull out a secant tangent, right? And we can't
We're back to
pull out a
the-
secant squared.
It's the same thing.
So we do the replacement, right? I can't pull out a secant tangent because that leaves me a tangent left behind. I can't pull out a secant squared because I don't even have one. But I can get a secant squared if I replace tangent squared with secant squared minus 1.
Is that a new one at the beginning of class?
Yes. Went upstairs and got one. And that was it. All right, so when I break that integral up, I'm going to have minus the integral of secant cubed of x, and then plus the integral of 1 dx.
You wrote a 2 instead of.
Two
a
and a
Secant.
B.
Secant cube.
It should get, and then that should
And
be.
that should be a
second.
secant.
Yeah, yeah.
I knew the second mistake, and I got stuck on the first one.
And I think you need brackets, yeah. Or
Um,
distribute
No,
the
she already
negative.
distributed it.
I'm
Oh, no,
distributing
she
the
did, she
minus,
did, she did.
but I forgot to distribute the secant. Okay, this is the integral that we started with. I'm gonna go ahead and integrate that. So I have the integral over here. I have the secant of x, tangent of x here, minus the integral there. And then we said the integral of the secant was the natural log of the secant of x plus the tangent of x. So now we're going to treat this as an algebraic equation and solve it for the I. So let's add this to the other side. So we have 2I is secant of x, tangent of x, plus the natural log of the secant of x, plus the tangent of x. So if I divide by 2, I have my integral of secant cubed.
No, it feels weird to add the plus C afterwards.
Well, just didn't want you to get confused about dividing your c by 2 and driving yourself nuts.
I
I
have
don't
a
know,
question.
because of like you,
I always put the c when I know I'm done.
yeah.
That's kind of like putting a period at the end of the sentence.
I have a question.
Yes, sir.
One way that I've like almost always written C is I'll always just put it like before the integral. So I'll just C plus integral.
That's fine.
That's okay
Yeah.
with you? Because I've had a lot of people tell me that that's disgusting.
No, I'm used to disgusting things.
Oh.
I've been married a long time. I've seen worse than a plus c at the beginning.
Let's see in the
all the
middle.
horrors. Yeah.
Secant tangent of the two plus C plus. the
So you would do a
natural
secant to the fifth that way, that's longer. So just be alert.
multiply.
So does that kind of answer your big picture?
Plus C of the two.
So I don't remember the rules until I'm actually doing it. I look for either pulling out a secant squared, replacing the rest, or pull out a secant tangent, replace the rest.
There's no limit to the amount of C's you can add.
What do you guys want to look at?
Square your C's if you'd like.
Yes.
You can just put multiple C's in there.
You can totally. And no one can say anything to
Trick
you.
things within trick things. Why do you get 10 of arc sine of that? Because you don't draw your triangles?
Well,
If you draw your triangles, you won't get those composite functions,
Like draw like inversion.
right? See, if your answer is the cotangent, then you go back to your original substitution.
Plus,
and then you
what's the guy's name?
can't you just do?
Let me post this question.
But I started doing.
I have wrong.
I mean, there's nothing wrong with your answer.
That
It just doesn't look like the ones I do, because I
Square.
triangle.
Secant.
So I wouldn't, don't lose too much sleep over, but if you're doing the review sheet and looking at my answers, then you kind of know how I did it.
Why?
So I got just something popped in my head here that's calculus related. Where'd my little towel go? Hit it back there at the good marker. That's where the good marker went.
It's hiding.
That's on my.
It wants to dry out.
I don't even know when you set that down, like it just.
She has to
It walked away. I did
Set it down right
it.
before it's happening here.
Walked away on its own.
Put that into web.
Okay, so, you know, I want you to realize the ones you know quicker than the ones you don't know. And so,
Oh, it'll be exposed. Yep, we're about to be.
Oh, yeah.
Oh, okay, this is just,
A sign.
that's just sign, yeah.
A sign theta.
No idea.
Yeah, I don't remember.
No, that's.
Wait, no, that's.
You're gonna get me confused.
Yeah, that's secant.
that's the, right?
No, I'm saying for the secant.
You do a secant substitution. Oh, you would use the secant formula.
Now that one is interesting.
That one's an actual sub, like actual like equals.
Oh.
Yeah, that one. Then I think.
Start a one.
Ooh.
One more. A version of the same problem. I can write a whole test just with this one problem. Permutations of this one problem.
That's acceptable and also terrifying if you don't know the one.
You can do them all the same way, but just take you longer. Right, some of these are zip and you're done, and some of these involve more than just zip and you're done.
Oh, are we actually supposed to
Well,
do
which ones are the zip and you're done done?
the first one?
First four.
Or sorry,
middle
the
four.
second one now?
Second.
The second one, this is a known formula,
The sign sub, right?
not even a sine sub, it's already known. If you do the substitution, which I think you did on your homework, you'll get the same answer. It just takes you 3 to 4 lines instead of boom, spit out the answer.
What you're saying is we don't need to memorize any of this. We should just use trick subs.
Just
for all
use
of them.
tricks up for all of them. We'll be here till Thursday, but
We're paying for it.
Wait, so we can get around memorizing things?
if you don't know it, then the tricks up will work. But if you do know it, what is this one? Inverse sine. So do I have a 1/2 out front?
Yes.
Not with the inverse sign. But I do have an x/2 here. That one's known. There's one more up here that's known.
Those four.
This one. What's this one?
1/2 arc secant.
X.
X over 2.
All right. Then of the ones that remain,
The third one is a secant substitution.
Third one is a secant substitution.
Yes.
Okay.
It's U to U.
Yes. It is just you.
This one's just a u du integral, right? 1 power more on the bottom than on top. So here you're going to integrate. Take u to be 4 minus x squared. Du is a minus 2x dx, and there's our x. So we're integrating -1/2 integral u to the -1/2 du. Right? And if I add 1 to the power and divide by the new power, I got u to the 1/2, I said, where did the a come from?
Sometimes.
Times 2?
Yeah.
So we get minus the square root of 4 minus x squared. But again, if you let x be 2 sine theta, you'll eventually get that. It'll just take a lot more work.
I think the first one and the last one use a sign substitution, then do some trig magic.
Okay.
afterwards.
We can do that. We can also do this last one with a double substitution. I can make that x squared. And then an x dx. And then the 4 minus x squared, and do this. And so I'll have square root of u here. Du times the -1/2 here.
Wait, yeah.
And then you're gonna have
What
like
about this x squared?
u plus 4.
Okay,
or
okay,
something
that's
like that, right?
How about x squared is u minus 4?
4 minus U.
4 minus u. And then you make 2 integrals out of this one. Right? Okay? And then the -1/2 is out here. This becomes u to the 1/2 times 2. And this becomes u to the 3/2 times 2/3. Blah, blah, blah. Put the u back in.
Can you show us like something that we should know?
No, I just did.
No, like another one, but like that we can just derive it
What do you mean? Just as is?
instead of like memorizing things, because my brain is not very good at memorizing. It's very good at just knowing how to do it.
Any
and
of them.
execute.
Any one of these you could do with the appropriate trig substitution.
Memory is the.
You
mother
can
of
do these with x is equal to 2 sine theta. And you can do these with x is equal to 2 secant theta. And any of the ones that have the 4 minus x squared would work with the 2 sine theta. Any of them that have the x squared minus 4 would give you the same thing with the 2 secant theta.
You just cut my work in half for
I
memorizing.
cut your work in half by putting more steps in all of your problems.
Well, I already because I can do that like logically.
You
But
can
like
also, you're never gonna get out of memorizing the trig subs.
I'm getting out of memorizing these trig subs. The 2 secant
Good
thing.
luck with that.
It's okay, we were here.
All right, so do you want to finish the ones that involve the trig subs? Finish the first and third? I'm not gonna make you, I'm here for you.
We do have a test over this.
I'm here for you.
Yeah.
Should probably do
I
it.
like
Could
trig
you
If it's only like 10
One
problems,
review
it's
is
not too
one
bad,
over-
just do the trig sub.
Yeah,
No, I
just fix
Have you
it.
seen the matrix?
You see everyone else's
Oh,
paper,
that's
they just write down the things and Jack is like
I mean, deriving is just way easier
Damn,
than
no, I can't
memorization.
copy off of Jack.
It really
This one.
Travis,
So here you go,
you
Sophie.
literally have no need to copy off of me.
All right, I'm gonna finish them. You can watch if you want, or you can play along. Either case, you need a dx.
I haven't memorized like a single thing on this page yet, but I will by Wednesday.
Okay, so the dx is 2 cosine theta d theta. Each x is 2 sine theta. So x squared is gonna be 4 sine squared theta. And then under here. All right. And then for the 4 minus 4 sine squared theta,
Just give us two
we
cosine.
factor out the 4 and we have a 1 minus sine squared. So when I write that as 4 times the cosine squared under the radical, I can take the square root of each term, get rid of the radical, and put a 2 cosine theta. Now let me rewrite that. I've gotten rid of the radical sign with the trig sub. We'll also get rid of the 2 cosine theta. I can take the 1/4 out front. And how do I integrate 1 over sine squared theta?
You change it to cosecant squared theta, and that's just a known integral.
Okay. We know how to integrate a cosecant squared. We're gonna go cosecant squared is cotangent. So it'll be theta. All right, now, if you just say that theta is the arcsine of x over 2, then you've got your answer written as a function of a trig function. So instead, what I prefer is to draw the triangle. Sine is opposite over hypotenuse.
So that leaves
Third
you-
side is always this. And so the cotangent is adjacent over opposite. So if I use this triangle, my adjacent side to the angle is the square root of 4 minus x squared,
over.
and the opposite is x. And then you don't have a composite of a trig with an inverse trig. Okay? Let's see, this other one I think should simplify to a secant integral. I think I've done this integral so many times, I already know that. Root of that is 2 secant x theta tan theta d theta. And so we've got 4 secant squared theta minus 4 under the radical sign. That stuff is in the numerator. That's going to be a tangent, pull out a 4, and you have a secant squared minus 1, which is a 4 tan squared. And all of that's under the square root sign. So I can rewrite that as 2 tan theta in the denominator. And so all that's left after canceling is the secant of theta.
Plus,
I did that one a second ago with a formula. Log secant plus tangent.
I'm trying to figure out theta.
And now figure out what the tangent of theta is.
Use even after.
X over 2 is the secant of theta.
Which you have to use even after.
Which 2 sides are the secant?
Hypotenuse over
Hypotenuse
adjacent.
over adjacent.
Yeah, but I
So this should be the x squared minus 4. Secant of theta is x over 2. And so the tangent
is that
is
over?
that over 2. So that little triangle right there keeps us from doing the composite with an inverse trig. Okay, so I had a question over. Let's see if I can remember it. In the review sheet.
Are we doing Koch and stuff like that?
Not a cosh, would be an upside down cosh. But it's not, it's an integral of it. Do you not integrate 1/cosh?
No.
So then let's not go that way. Let's write it in terms of stuff we know how to do. I can't take u to be the denominator because there's no du term in the numerator. I'd always look for that first. Okay, I can get rid of this term if I multiply top and bottom by e to the x. And that's what I'm gonna do, try to get rid of that term. I'm multiplying top and bottom by e to the x. That does give me an e to the 2x though, doesn't it? What is e to the x times e to the negative x?
Oh, one.
1, because you e to the 0.
And then
Why
you
is
can-
that a preferred integral?
you can
QD.
do the first tangent.
Yeah, now you, when this power is 1 more than that power, and we got a plus sign here, we can do a u du. We got a minus sign here, we can still do u du, but then we'd have partial fractions. Right? So if u is e to the x, not e to the 2x, then du is the numerator.
Why wouldn't you just do, you did, oh wait, no, that doesn't make any sense.
If
Yeah,
they're the same power, then I take the whole denominator. But if one's 1 power more, or twice the power, then we would do this deal. So if this were, yeah, forget it, I won't say that. So I now have
or sorry, yeah, you squared
the
it.
du and u squared plus 1. Right, and if you recognize that one, you're done, otherwise you do a bunch of steps.
Can you show me the steps?
I'm not going to.
Because no one's ever done the steps. They just tell me to memorize it. That's not. my
I don't want to do the steps because they take, would you take u to be 1 tan theta? Du is secant squared theta d theta.
Okay, okay. I just was
It's like
told to
trig.
memorize this.
Well, it's easy to memorize this. That's the arctangent of u.
I have like no reason to understand that, so like it doesn't
Because the
make sense.
derivative of this is that, so the antiderivative of this is that.
Okay, yeah, but like,
Look up a proof online, reciprocity.
Yeah.
yeah.
For that interesting.
It's self.
I don't want to hammer in attack with a sledgehammer. I just want to smack it out like that. Listen,
Can you not make use the whole denominator?
no, because then it's gonna have an e to the 2x as its derivative. We don't have an e to the 2x on top.
It would have just become 2e to the x.
No,
It would be
no,
2e to the 2.
It would be 2e to the 2x, and I don't have an e to the 2x. So what you said would be true if the power on top were the same as the power on the bottom, you take the whole bottom. But if the power differs by a factor of 2, then you try to write it as a inverse trig function. Okay? If you want, I'll put both of those on there. Same power, different power. Golly, I should have brought a piece of paper and wrote the test as I was going. Because I've already found several problems I want to put on.
You have the recording.
I do, but then I'd have to watch it.
Just put it on 2 times speed.
Yeah.
Can we do like a weird with the square?
A weird
Yeah.
complete square.
Pesky radical.
Pesky radical with coefficients and minus signs and ooh. Ooh.
I like the word best.
2 times speed.
Sketty.
I want to get steady though.
That's for going to market. I am.
Seems fun.
This is nice.
9.
Pesky enough for you? Complete the square and have fractions in there?
That's very.
Fractions, oh.
Fractions are better than decimals.
I would say so.
Now we're gonna blow a sign too.
And blow a sign.
Write like 3,000
The
decimals.
minus sign in front, blow a sign and have to add fractions together. The ultimate test of the calculus 2 student.
And that's why bridges don't match up.
And somewhere in here, you have to use a double angle formula.
Oh.
The collective groan. It wasn't a groan, it was a How did you guys all know the at the same time?
We,
I mean, you
we,
kind of prompted it.
Yeah.
you're like the conductor.
For me.
Yeah, to complete the square.
We can take out that negative, right, and just put it back in later.
Yeah, I would do that. I would do some scribbling right here. And if I had a coefficient in front of the x squared, I'd have pulled it out as well. Right?
I don't know if I did this wrong or if it was just a lot easier than I thought it would be.
Damn,
do it.
some nice answers you got there.
Mine's terribly negative.
You said 81 minus
The good news is,
So it shows up on the screen.
I have a question. No, I don't know what my question is. Is it worth it? I may or may not. Yeah, I'll take it right now. You just write it last. With your water? Yeah, I'm trying to think. Is it worth it to see the answer, or do I just need a
do you want me to
picture?
show you the answer? I could send.
Oh,
you-
no, I think I had the answer.
I can stall for you.
Yeah, we can stall again.
Oh, God, here we go. Nah, just get it going. I'll, if that happens again, I'm gonna take my entire stuff and I'm gonna be peeing with a backpack on.
I won't change anything.
I mean, yeah, but then I will know where my phone is.
Got it completed?
We will go to your formula sheet and
Swear,
change
yeah.
the sign of one.
Right, reverse it. Put that behind.
No, he's taking his stuff, remember? We're just gonna completely rearrange the entire room so that we're in groups.
Oh.
Table groups that are all in triangles.
I'm good with
No, they're in
Yes.
hexagons.
That's too big.
Oh, you're right.
My pockets are too little.
No, you can't take the negative outside the radical.
But not the radical, sorry.
But we're gonna write it as a squared minus u squared.
What if we put the chairs on the inside of the triangle?
That's
just to
garbage.
be easy?
So it would be.
I like that.
Yeah, it should be a positive 81. You should have a positive 81.
You're like, yeah, yeah.
But.
Looks like
inside
the
positive,
last
and then we're gonna put it right here.
Yeah, mine is very like.
Yeah.
Staring at each other.
And then on the
All right, so
inside.
here we go. Half of 9 is 9 halves.
What?
9 halves squared is 81 over 4.
Oh, I screwed that up.
But I actually put in a negative 81 over 4. So out here, I put in a positive 81 over 4. Because this sign goes on that. So I have to do the opposite out here. I see that? Yep. And then this factors as an x minus 9 halves all squared. But in order to make that recognizable, I'm going to rewrite it under the radical sign as 81 over 4 minus x minus 9 halves squared. So that it looks like an a squared minus u squared integral. And now you got to do a trig sub. What's your trig sub?
X minus 9 halves equals 9 halves sine.
Right. And so dx Yeah. 9/2. The cosine theta d theta. So see if you can write that as some sort of cosine squared integral. A lot of crossing out. What happened here? Oh, you see where you messed up?
Yeah.
They wanted a messy complete the square, and I gave you one. So somewhere down the line, you're gonna be integrating a cosine square with some kind of junk in front of it. You want to get rid of the pesky radical sign?
She's getting ready. She's like, all right, I'm gonna have to move somewhere.
Please substitute yourself. Well, so you just substitute that.
Not do it.
No, but what if we all like, giggle like we did do something?
And we're gonna tell them.
Okay.
change one formula.
Okay, so the thing we're doing today is we're pretending like we did something. Okay.
Oh,
Change
as usual.
Change his pencil so it's like facing the other way. Or that, or something, yeah, so it's like, it looks like this other way.
Okay. Here,
Open his
I'll-
notebook.
Yeah,
Just open to a random page, don't do anything else.
Wait, no, just draw like a random doodle somewhere.
No, don't do that. That's
No, the second that he walks in, flip it shut.
Okay.
But don't actually draw anything.
Yeah, don't actually do anything.
Did you see what we drew on the whiteboard yesterday? You did draw.
I should come up with a mango, it seems like fun.
Yeah, you should.
All right, so when you substitute that stuff in, you get this,
This is.
and then working under here,
I got dogs.
That's actually so good.
You all draw good stuff.
Can I see? Oh my.
1 minus sine squared is cosine squared.
9 times 9.
Mostly because.
And so that's under the radical. We put the square root sign back on all of that. And so I can simplify that first batch as a 9/2 cosine theta.
Yeah, so this is just 81 times.
And then it's multiplied with another 9/2 cosine theta.
Nice.
Well, I do.
So I have an 81/4 times the integral of cosine squared of theta. You have that one memorized still?
Theta over 2.
Theta over 2 plus sine of 2 theta over 4. But then you have to do the 2 sine theta cosine theta.
Wouldn't we write it sine times cosine over 2?
You can, because I'm gonna write that now with my identity. And the 2's will cancel. We did that so that we can go back to our triangle now. I gotta find a triangle from here. From there, I can say that x minus 9/2 divided by 9/2 is the sine of theta. I can make that look prettier if I multiply top and bottom by 2. 2x minus 9/9 is the sine of theta. Just multiplying that by 2 and that by 2. And so that's the sine of theta. We'll draw the triangle to get the cosine of theta. Sine is opposite over hypotenuse. And then this should simplify to that thing. And then to get the sine, to get theta by itself, theta is the inverse sine of this. So our final answer is 81/4 theta over 2. So we said theta was the inverse sine
2x
of
minus 9.
2x minus 9/9. divided by 2. I'm going to cancel the 2's here. And write that right here, 1/2. Now the sine of theta was 2x minus 9 over 9. And then I have the cosine of theta. Using that picture is that funny radical sign, 9x minus x squared over hypotenuse plus the constant. I'm simplifying everywhere.
I decided to make life hard for myself and I made sine theta equal to 9 times x minus sine over root 2. And I
Yeah.
wrote it out like that.
I have a question.
That's okay.
Then I ran out of room.
That's okay.
Like, as the cosine, if we put it as the square root of 81 over 4 minus x minus 9 over 2 squared, is that the same thing? Like this?
Oh, yeah, in the completed the square form, yeah. I just wanted less to write. Yes,
Can we leave sign in terms of that, or do we have to say?
yeah, you don't have to simplify it.
So that could be
Yeah,
opposite.
that's right. And then your stuff, your third side, you're finding out which one.
And we could just.
No. None of that.
Okay.
None of that.
So what else? We've got the trig subs, we got integration by parts. You're good with partial fractions.
Yeah.
The miscellaneous problems that were in 7.5.
Actually, one question on partial fractions.
Yes,
When do you
control.
use the AX plus B, like in
When
the,
one of your fractions is a prime quadratic
Good
factor.
job replicating this.
So this is considered a repeated linear factor. This is considered a repeated linear factor. This is considered a factorable second degree polynomial. This is the case where I would have the term with an AX plus B on top. Okay, so this is the only one that's quadratic and prime.
what about like X squared
Yeah, but I'm
plus
gonna do-
3X plus 1?
If I had an x squared plus 3x plus 1 as the only thing in my denominator, I would complete the square.
And what if it's multiplied by like, X or
If
X
I
squared?
had this, then I would probably try partial fractions with completing the square. But you won't have something that messy. Right?
We have something
Can you do one like,
I can't do one like that now because I'm out of time, but I'll be glad to stick around and do one with you. Anybody else from Lake, you can. Good luck.
I gotta go look through my.
Oh, that.